Hello and welcome everyone. Thanks for joining me at this RoboCon 2021 presentation. My name is Diogo Rede and I'm an engineering lead at Farfetch, currently leading a test automation team. As a team, we work on supporting several development teams that develop e-commerce websites, and I'm here today to talk to you about how we automate our tests for these websites. The presentation's title is E-commerce Web Automation at Scale, but what's that all about? Well, it focuses on how to implement a test strategy for multiple websites with a high level of similarity using Robot Framework. It's far from being a standard approach to using Robot Framework, so be open-minded and bear with me while I walk you through the challenges we try to solve. So, first we'll have a glimpse of the Farfetch Platform Solutions business area, quickly moving on to present you with the challenge we are going to be discussing on this presentation. We'll start by dissecting the anatomy of an e-commerce website, which is likely familiar to all of you, and then we'll move on to our generic tests approach. Later, we'll take a peek at the sample project. Note that although this project reflects some of the ideas used on our solution, it's just meant to be a very simplistic way of demonstrating some of the concepts and doesn't fully portray the complexity we deal with. Finally, we'll have some closing notes before saying goodbye. So, I work on a particular area at Farfetch called Farfetch Platform Solutions. To explain what it is, I'll quote our About Farfetch website. So, it's a suite of white label solutions for luxury fashion brands and retailers. And these solutions are built on the Farfetch platform, providing the same capabilities and scale as our marketplace. So, we have a couple of solutions, and one of them is an e-commerce website based on our core components, but fully customizable according to the client's requirements. So here's the challenge. We had multiple tenants, each with his own client-facing e-commerce website customized to his needs, and we wanted to have automated tests on each website to increase release confidence and decrease testing effort. The sites were designed to be responsive in order to have increased usability for each device type, so desktop, mobile, and in some cases tablet size will have to be considered. Adding up to this, users navigate on multiple browsers, so we had to support that too. Based on some analytics and ease of automation, we picked Chrome and Safari. We then identified roughly around 100 test cases that were prone to automation. Doing the math, we would end up with close to 9,000 tests to automate. So just a note here, even though with our solution we were allowed to test all these conditions, we didn't end up implementing and executing all the tests under every condition for every website. We follow a risk-based approach for selecting the tests for each website, but it's still a very high number of automated tests to create and maintain. Given the challenge, we started investigating the most effective way of automating e-commerce related tests. We all know what an e-commerce website looks like, right? I mean, sometimes sites from completely different companies look and behave pretty much the same way. For any of these websites, we are likely able to identify a couple of pages, such as the home page, content pages, sign up, product listing, product display, wish list, bag, account, checkout, among others. We can go even further and find smaller reusable components inside these pages, such as a summary that can be seen on the bag and checkout, or address book, which is usually managed on the user account or during checkout. We also have reusable controls, for instance, some fancy dropdown that may be customized to show more than simply the value we're about to select. Given these assumptions, we decided to come up with the generic tests approach, meaning we should be able to create automated test cases that would run on most websites with only a few adjustments. We had to start testing our concept, so we picked Robot Framework as our test framework naturally, and Selenium as our browser automation driver. We started small by removing some variables from the equation, so our initial challenge was about automating test cases for all websites, but only on desktop and using Chrome. We created a generic tests package, which would be reused by every test automation project and follow the very common structure, dividing it in resources and tests. Inside resources, we split the files by components such as the bag, login, register, etc. And for each component, we had our own robot keywords a YAML with web element locators for that component, and any other data variables that could be useful. Inside tests, we just separated the test types between component and end-to-end. The next step was bringing these generic tests into an actual project. We created the packages folder, which would later contain more packages for other purposes, like we'll see. We knew these tests wouldn't simply work out of the box. Locators would be different, some flows would be different from site to site, and we didn't want to have our keywords filled with if-else conditions, which is bad design. So we came up with a strategy for overriding any keyword or variable we wanted simply by following a naming convention. If you name the file with the OR prefix, which stands for override, the keywords in it would take precedence over the original ones in the generic tests package. Then, for a matter of consistency, we replicated the generic tests structure on the tenant folder. Here's a simple example using keywords related to the product display page. On the generic keywords file, we have actions like select size, add to bag, add to wishlist, among others. Size selection is most commonly done through a drop-down component, so the generic file has that type of selection. But some websites opt to have multiple buttons displaying the sizes. So for those websites, we would implement an override keyword with the same exact name, but with a different implementation to support this behavior. Now you may be wondering, okay, but how does that work under the hood? This isn't natural behavior. Well, we use two very powerful robot framework features, which are pre-run modifiers and listeners. On the pre-run modifier, we implemented methods which would search for our robot and YAML files and change the import order before test execution. Like you can see on the code sample, on the suite visitor, we check if the suite has tests, which means it's a test suite file, and change its model to apply the order we want for the imports. We'll dig a bit deeper into it later on. This solves the issue of variable override, but we're left with keywords with the same name, which will raise a naming conflict error. To solve this, we use the listener, and on the start suite stage, we call the built-in set library search order, so Robot Framework gives priority to the override file's keywords. Well, so far so good, one problem down, but there were far more challenges to be solved, although this was a complex one. So one of those other challenges, a bit on the side of it all, was how we assured the conditions and initial data to execute our tests in a generic manner. So we had multiple websites, and like we already said, these were built on top of a common platform, a platform that is exposed to REST APIs. So why weren't we taking advantage of that? We grabbed the request library, and in no time we had a collection of keywords that solved most of our setup problems. One call and we could create a user, create a user unless it existed, reset the user password, add addresses, clear addresses, find products for our tests, etc. Other setup actions we created include cookie injection to skip login, or cookie injection or local storage data injection to skip annoying things like pop-ups that show upon a random number of clicks. So this work made setups much faster and much more reliable. Still, we were not satisfied with things such as test flakiness or simply having to create override keywords for the slightest difference in behavior. We decided we could overcome many of these problems by creating an extension of the Selenium library based on our reality, aiming for resilience and generalized behavior. We implemented it with multiple resilience mechanisms, such as assuring the element is visible and interactable if we need to click it, and retrying the actions in case they failed at the first attempt for any reason. This is done through the resilient keyword decorator you can see above the functions in the code sample. We'll dig a bit more into it later. We also do things like validating the result of an action. For instance, when we input some text, we verify the text was actually on the field, or we would retry the action, like you can see on the input text example. This solved some issues we were having because sometimes the tests were too fast and the form wasn't fully ready or something similar to that. One other thing I don't have depicted on this code example, but which also solves a lot of flakiness issues and also maintenance and all that, is the fact that we normalize all text before any assertion, so tests don't fail due to trailing spaces or case-sensitive matters. That's a very usual problem. Another extremely useful feature is a drop-down component abstraction, which allows us to perform any action or validation on a native HTML select elements or on a custom drop-down made out of divs, line items, or any other kind of elements. All this is taken care of in one keyword, so we rarely need to override the keywords that handle this kind of component. Like you can see on the code sample, all we do is check if the locator element is of type select, and from there we choose how we interact with it. We noticed the advantages of doing this when we started implementing mobile tests. While on desktop, custom dropdowns are a common thing, when it comes to mobile, native dropdowns are preferred for a matter of usability and consistency. These are just some examples of what you could do by extending the Selenium library, and I want to leave an important note here. Anyone could rightfully argue that these aren't the best test automation practices and that they may hide actual issues on the website. But given the premise that our business is not about life and death, we can assume that if a button doesn't work at first, the user will probably just click it again, and we can live with that scenario. Just keep in mind that the kind of business you are testing has a deep influence in these test design decisions. Well, it was now time to face the full challenge and add the remaining variables. So yeah, we literally added the configuration variables, which were the device and the browser, based on which we would create our Selenium driver and select our overrides. These overrides had now had more naming conventions, as you can see on the file tree. We now used composed file names with the device and or the browser name to identify the priorities. We added these variables to the algorithm we had to calculate the overrides order, and the remaining flow was kept the same both on the pre-run modifier and on the listener. By simply switching these configuration variables, we were able to run multiple tests without changing a line of code. Others require some fine-tuning with more specific overrides, but we rarely had to override an entire test case. So this spared us a lot of effort. So now we had all these possible variations, which required different configuration variables and even test sets for each execution type. We then came up with the concept of an execution profile. We already had the base configuration files, which are the config.yaml, where we have our main configuration variables, and the config test set.yaml. Then, by adding the profile value as a suffix, we could complement or override the base configurations. In the configuration file, we could now, for instance, override the device variable and perhaps add a couple more. In the test set, we could add more test tags and names to include or exclude. This made it very versatile to create different types of profiles. We also felt the necessity of standardizing the projects with a base configuration file, with things such as extra pip indexes from where we would fetch our packages and the project dependencies list. We call these files the robot project YAML and the robot project log YAML. As you can see here, from a structural point of view, they are the same. The difference is that the log file is auto-generated when we install the project through our custom CLI, which saves all project dependencies versions. We used to face issues due to transient dependencies having new releases that had breaking changes and broke our projects. Now we just install using our rf CLI install command, and with the type parameter set to logged, we are able to replicate a functioning environment every time. Now a bit of context about our hybrid packaging. We use setup tools for packaging, so we create a regular package with a setup by file and a regular package structure. The different bit here is the robot folder, where we place the files we want copied to our projects when we install them through our CLI. So setup.py is totally standard. It will fetch any folder that has an init.py file, and then we added the manifest file to make sure we include the files inside our robot folder like you can see on the bottom. And that's it. Then we had the CLI, so I'll just do a brief overview. It has other functionalities, but these are the ones we use the most. The project dependencies installer, which is based on the files I've just shown you, helps us install all of our dependencies and hybrid packages with both Python and robot code. It's quite simple. We have our packages on a pip-compatible repository, so we use pip to install the packages, and then there is an extra step that fetches the robot files from these packages and imports them into the project. It naturally also installs all the transient dependencies since it all starts with the regular pip install command. It can install from the robo project file or the log file by using the type parameter. It can also automatically create virtual environments so you don't mess with your global Python instance by passing a path on the Python env path parameter. These are just some feature examples. Among other things, we also added a custom test runner to the CLI, which makes it easier to execute tests by enabling to select the profile on the command line, choosing how many parallel threads we want to use, which naturally uses some paybot magic behind the scenes. And we also have a parameter that automatically reruns tests and one that sets the maximum number of tests failed that allows the rerun to happen. These simple features simplify our lives a lot. So now let's go dig into some code, shall we? Okay, so what do we have here? We have the packages folder where the code for our packages will live, as you can see here. We have a pip repo folder which will just serve as our pip repository local server, and the project folder which has the robot project. So here in the packages, we already know the structure, but I'll want to dig a little bit deeper and go to the Resilient Selenium, which is the main class for the Resilient Selenium package, and explore this Resilient keyword decorator. So here, what do we have? We have a decorator pattern, so we use this method call, and it wraps the function, and it gives us access to the function itself, to the args and the quarks of the function. And with this, we can do pretty much anything before the function, to the function, and after the function, if we want to run the function at all. But yeah, here we have a retry method, and inside the retry method, what we do is we look for a locator argument. So every keyword must have a locator in order to be able to use this decorator. And then what we do is a couple of retries over here. So we check for the visibility. If the check visibility flag is true, we let the stale reference sleep if the stale resilience is true. And then if there's a timeout, well, we just have to assume that it really failed. So yeah, this is a decorator using this retry mechanism. And here just a little detail, but an important one. You have to add these two properties to the decorator method here so that the keywords are added to the robot namespace or you won't be able to use them. So yeah, this was it about the decorator. So let's go to our project. In our project, we'll start by installing these packages. For this, we'll use this rfcli install with the Python env path as default, which we'll install in my global Python instance. So let's run this, see what happens. And there it goes, installing our packages and all its dependencies, of course. Should just take a few seconds, bear with me for a while, and there we go, here we are. And it also says in the end that it copied the non-Python files to the packages ext folder, which is here. So yeah, we have our tests and our resources all over here inside our project. We also have this auto-generated robot project lock. Remember I mentioned this? Well, it has all the transient dependencies, so we can later on install from this package and make sure we have a stable environment. So from here, where do we go? Well, we can check the config YAML, and here we see we have the base URL for our tests, which will be farfetch.com, the device, here is desktop, browser Chrome, and the timeout. These variables are all assumed are fetched, in fact, by the Resilient Selenium library. So let's give it a run, right? See what happens. Here, just one little more detail. we have to import the pre-run modifier on the robot command. So here we have this pre-run modifier parameter. Let's run this and see what happens. So please ignore that little error over there, and let's see our browser here. This is a failed login test, so the login should fail. Let's see how it goes. Okay, there we go. An email, a password, click sign in, and yeah, okay, there was an error message over there, so we are good. This test is this one over here on the component login and successful login. Okay, so it does a go to login page, inputs credentials, submits the credentials, and validates the login failed. So it runs just fine. It's our generic test, and it runs just fine for desktop. So now let's try something. Let's add the profile mobile over here. So mobile. What this will do is that it will also use the configurations from this file over here, which has the device overridden as mobile. So let's try to run the tests again and see what happens. Here we go. So it resolves the driver well. So we have a mobile resolution. And now, well, as you can see, there is no login button on the header. So you need to open the burger. So this test will naturally fail. Just wait a couple of seconds and it should fail anytime now. Yeah, there we go. So it was trying to find this locator over here, which doesn't exist because the locator even has a desktop suffix in it, so naturally won't exist. So what do? We override some stuff. I already have these files over here prepared, so we don't lose much time. And what we do is we go to the tenant folder, to the resources, which are empty right now, and we just paste this inside. What are these? These are some locators for the header. So it's the login locator, which is now go to login mobile, and the burger locator, which is hamburger button. And then also on the login, we have to override the keyword, which is the go to login page keyword, because now there's an extra click on the burger before clicking the login button. So let's try to run this now and see what happens. And the driver is starting, and there it goes. So now we should be successful. I mean, the test should fail successfully. So there we go. It's taking a little bit, and okay. Managed to get to the login page, managed to input our data, and success. Just like that, we could reuse the test, and on a different resolution, we could do the same for a different browser, and that was our whole goal. So yeah, guys, so success. And now some final notes to wrap up. What were we able to achieve? Well, the ability to reuse robot tests and keywords. Then we reduced the test design phase effort, which took a big part of everyone's time. We found common ground for anyone starting a new robot project. And ultimately, we found a way to easily write automated tests with multi-tenant device and browser support. The takeaway from all this? Well, custom libraries, pre-run modifiers, and listeners are your friends. So if you haven't used them yet, you probably should give them a try. Thanks everyone for watching. Hope you enjoyed the content and eventually took some notes for your own projects. And see you all around.
Hey, welcome to RoboCon.
Hello, Joe. Thank you.
Great session. Let's just jump right into it because we have a bunch of Q&A and we have like 3 minutes to jump through it. So first one's from Brian. And Brian wants to know, is the resilient keyword decorator available as open source?
Not at this point, but I know the company wants to contribute some more to the community, so it might be pretty soon. At least that's my intention.
Awesome. Manny wants to know a question about the structure of your keywords test. You mentioned split up the websites into components. Does one component mean one website, similar to page object pattern, or one reusable part of the website?
It's one reusable part of the website. So it can be a smaller or a bigger part. It could be a small component, such as a dropdown or an address book, like I mentioned, that is then reused across multiple pages, or it could be just the whole page. It sort of depends on how you deal with things. If they're too complex, if the files grow a lot or not, we just go from there. We don't have a sort of a rule.
Great. This next question is from Slido. And they want to know from Ed, with the automatic library search order, do you have issues with it getting the wrong order?
Well, it's software, so at first, yeah, we did have some bugs. We just solved one sometimes this week or so, but it's just a matter of actually getting it right. After that, the keywords will be resolved the way you want, and you won't run into any problems. You just need to follow the rules. It's all about conventions.
Right. Yep. Absolutely. Next question is from Manny. He says, you're using YAML files for your locator selectors. Cool idea. I really want to try that. Any hints for someone who always adds typos into YAML files, like incorrect spacing?
Well, I'm not sure how I can answer that. Well, there are always validators. We don't really use any. What we do usually is that we have our tests with the exit on error setting, which usually cuts the tests off if there are errors on the files or something like that. So that would be a start, I guess. But there are always ways to validate the YAML files. Yeah.
I wonder if there's a linter or something. I could figure that out. Next one's from Nils. Nils says, very impressive setup. How much development time went into this?
Wow, this is actually like 3 years old. When the team started, I started off the team, and we've grown a lot since then, because we actually started doing all this just using Robot Framework. We didn't use Python at all, and then we sort of matured our ideas, and then we were like, okay, this is starting to be really hard to maintain, and we started moving things to Python. And we always have new challenges. The development time we put into these components, it actually depends on whether we have to actually work on the automation part of the websites, or if we can work on these more basic pieces. We are a team that, I didn't mention that, I think, but we are a cross-support team. So there are multiple teams, multiple QAs developing automated tests. And what we do is try to make their lives easier by developing these solutions. And then we also help them implementing the tests, giving maintenance to the tests in harder situations. We also do some training. So it's a lot. We do a lot. So we don't really count the development time.
Awesome. And time for one last question. The overriding stuff you've accomplished using pre-modifiers is basically object-oriented design inheritance, isn't it? Would you wish Robot Framework would support object orientation as built-in concept?
I'm not sure, to be honest. This is sort of can be controversial, right? Sure. Because we want Robot Framework to be as simple as possible, to make simple things and pretty code. But sometimes, yeah, we do want some more programmatic things, such as this if-else, now supported natively with the Robot 4.0, right? But there are always the two sides of the coin. So I'm not going to give much of an opinion on this. Sorry.
Perfect answer. All right. Actually, that's all the time we have. Thank you so much for contributing to RoboCon. Really appreciate you. And folks can definitely check you out in the speaker lounge in the conference area. So what area are you going to be in? There's a light area and a dark area.
I haven't explored it a lot, but I can pick the light one, I guess.
Okay, perfect. Sounds good. Thank you so much. Really appreciate it, and we'll see you in the Robo venue. Cheers.
Thank you for having me. Bye,
Anytime.
Joe.
Thanks.
Bye,
Bye-bye.
everyone.